Hey guys, good morning. I hope you're doing well. So today I want us to talk about rigid transformations or rigid transformations, depending on how you pronounce that. And I know you're seeing a lot of words and already going like, what are these words doing in mathematics? But words are just used to describe things. So rigid, the word rigid is just an English word that means, let's see, rigid is simply something that is unable to bend or be forced out of shape or is not flexible. So rigid is something that is not flexible. If you're a rigid person, then you're not flexible. Some people complain about that. And to transform something simply means to change its position or its shape or its size or orientation. So don't let these words scare you so much. A rigid transformation can happen to objects, and we've been talking about congruent objects that are the same shape and size, and you guys created some cool patterns using congruent shapes, and you performed some transformations on these shapes. Some of you are flipping them around, some of you are flipping them upside down, some of you are rotating them or moving them. So what you are doing is rigid transformations. We see rigid transformations every day. Right now, you're probably moving your hand to write somewhere or moving your hand to click. That motion of moving your hand from one position to another in math is called a translation or a slide. So these rigid transformations are really part of our lives every day. We just do them without noticing it. And I just want us to study them a little bit. So let me read this, what it says here. A rigid transformation, it's also called an isometry, but don't let these words scare you. These don't even need to be there. But just in case you find the word isometry somewhere, or isometry somewhere, that is what it means. It's a rigid transformation. It's a transformation of an object that does not change the shape or the size of the object. Now, I began by looking up the definition of rigid, and we saw that it means something or someone that is not flexible. So a rigid transformation, therefore, is one that does not change the shape or the size of an object. Now, I'd like for you to write this down. In a rigid transformation spelling, the object and its image are congruent or the same shape and size, right? So please write down these notes. The object and its image in a rigid transformation are the same shape and size, the same exact shape and size. They are congruent. This is a key idea when talking about rigid transformations. So there are three rigid transformations, and one of them is rotation, which in simple terms is simply to turn something. If you turn something around, if you turn around as you're dancing or something, then you have performed a rotation. Reflection is the second one, or in simple terms, to flip something. If you flip something about an axis or about a mirror or about a line, then that's a reflection. And translation is the last one, and that's simply sliding something the way it is from one position to another. When you slide your cup on the table, that's a translation. When you move yourself from one position to another and keep the same posture, that is also a translation. So I want us to look in detail at each of these rigid transformations. We'll start with reflections. Again, these are so many words that might confuse you, but each of us knows what reflection means. When you go to the mirror in the morning, you see your reflection, right? Reflection is simply flipping something across some line, right? So I would like for you to write the definitions of this, especially the words that are underlined. If you want to, you can write the whole thing, but I'm only requiring you to write what's underlined. So reflection is movement that results in the shape flipping across some line. In this picture here, this hand is flipped across the line, and that line is the surface of the water. And in this picture here, which is more mathematical, this triangle looks like it's flipped across that line. So the lines that we'll be using to reflect will just be the x-axis or the y-axis. And let me show you what this looks like in on a simulation here. So I have my object. My object is this triangle here in blue, right? And I hope you can see that as I move the object, the image appears on the left. The image appears here in green, right? Some key ideas about reflection is that the object and the image are always the same distance from the mirror or from the line of reflection. or from the axis of reflection. So each point on the object, I hope you can see this point here is 2 units away from the mirror, and then on the other side of the mirror, this point here is also 2 units away. So no matter where the object is, it's always going to be, each point on the object is going to be the same distance from the mirror on either side. Now this is reflection in the y-axis, because this vertical red line is the y-axis, but it can also be done in the x-axis. Let me change the mirror to be the x-axis. So if I change this mirror to be the x-axis, I hope you can still see. Let me zoom in a little bit. if the x-axis is my mirror, still the distance between the mirror, which is the red line, and each of the points, because if you look at this point where the cursor is, I hope you guys can see the cursor, it's 5 units away from the mirror, and then on the opposite side of the mirror, this point here on the image is also 5 units away from the mirror. So that's the idea behind reflections. The thing to remember, and you can write this down as well, each point on the object is the same distance on the other side of the mirror as each point on the image. Let me repeat that. Each point on the object is the same distance on the opposite side of the mirror as each point on the image. I'm going to show you an example of how this works, but I want you to write that down. So the line acts like a mirror, and the shape is usually drawn on an x or y coordinate. Most often the line that is used as the mirror is either the x or y axis. I already said this, but any line works. So let me show you some of what I'm going to be asking you to do. So if we have a question here, and they want me to draw the reflection of this shape in the y-axis, right? So the y-axis is this vertical line that goes up and down. Now I'm going to look for each point on the object, and then I just count the same number of units on the opposite side of the mirror to find the image point. So this point here, right, this one here where my cursor is 1 unit away from the mirror. The mirror is the y-axis. So I'll go to the opposite side of the mirror and count 1 unit and then click, right, and the image shows up. That's the image of this point. Then I'll go to the next one, opposite side of the mirror, count 1 unit, right? I'll go to the next one. This one here is 2 units away from the mirror, so I'll count 2 units on the opposite side, which will be there. This point here is 2 units away from the opposite side of the mirror, so it has to be directly across the mirror, so that will be over here. This one is 3 units away, so I'll count 1, 2, 3 units and put it over there. And lastly, this point up here is also 3 units away, so I'll just go straight to the mirror and count 3 units on the other side, and then I have my image. So this is the flipped image of this object, this blue shape, when reflected across the line across the y-axis. So I can check my answer and you'll get a check mark like this. So that is a reflection. Let's look at